Okay, what's this? Okay, what is going on? Okay. Not sure why this is up. I need to get out of it.
Or I could end my show.
No, don't worry about it. I'm just not sure why. There we go. There we go. Is everybody seeing my screen?
I'm, I'm
Yeah.
seeing you.
Okay, on my screen.
Your
Yes.
screen. Your screen. Yeah.
Yes.
Yes.
See us.
Okay, good, good. All right. So let's get started here. So I want to welcome everyone to today's episode, episode 9 of season 7 of Environmental Fridays. It is personal. There you could see our the link to our page, our website. And we, for this, I was going to say semester, but this season, we have 15 episodes, 16 guest speakers. You could see here where our guest speakers come from. Today, our guest speaker is from Jamaica. I think you are the first from Jamaica. Hopefully, you would not be the last from Jamaica to speak and be a participant in our Environmental Fridays. So, as you could see here, our November schedule began last week. Today we have Mark Harris. He will get introduced here pretty soon by our co-host today, Phaedra. And you could see next week, we go to University of Minnesota, Craig Parker, and he will talk about environmental impacts on the African lion. The following week, we go back to Trinidad and Tobago, dealing with Tobago oil spill that occurred, I believe, last year. And then Mark is on here too, my friend, colleague, Mark Moreno. He will talk about green architecture to close off our November schedule. So one of the most, at least it's claimed that one of the most iconic photos in throughout human history is this photo that we are looking at right now. It's called Earthrise. And this was taken by Apollo 8 astronaut Bill Anders. If you want to learn more about it, you can look at the QR code, or you could just look up Earthrise in YouTube, where he gives a interview. So Earthrise actually was the start of the inspired the start of the environmental movement. It inspired Earth Day. And so it is a very significant photo in the environmental movement. Our focus in Environmental Fridays is what the United Nations Environmental Program designates as the triple threats to Earth, which is pollution, climate change, and loss of biodiversity. And so today, our presentation would be an overlap over, I believe, climate change and pollution, and these things are all interconnected. One of my favorite poets is Emily Dickinson. I think there is some relevance to what she said in this poem. If I can stop one heart from breaking, I shall not live in vain. If I can ease one life the aching, or cool one pain, or help one fainting robin unto his nest again, I shall not live in vain. I think we could apply that to our environmental activism and our concern for the environment. Any little thing that we do could help. So my co-host today is Phaedra Wright. She is the founding president of Greater Empower Tutoring, and the mission for her organization is to connect, empower, transform. She is an educator, of course, an entrepreneur, and mostly, as she said in her bio, a proud boy mom. She has taught children from pre-K to 12, and at the collegiate level as well. Phaedra, it's your turn to introduce our speaker. You could add a few more things to what I said in the intro so we get a little bit more sense of what you do. Phaedra.
All right, good morning. Thank you, Dr. Murray. My name is Phaedra Wright, and as Dr. Murray has so wonderfully summarized, above all, I'm a proud boy mom, but in the work sector, I do work in the field of academics, helping our young people realize their potential, helping them shine, mainly in the areas of math and Spanish. But the purpose of me being here today is to introduce today's speaker. We are in for a treat because we have with us Dr. Mark Anglin Harris. Dr. Mark Anglin Harris is a professor of environmental chemistry and applied climatology in the Department of Biology, Chemistry, and Environmental Science at Northern Caribbean University in Jamaica. He obtained his Master's of Science in Soil Science and PhD of Environmental Geochemistry, both from the University of Adelaide, Australia. His undergraduate degree in geology and physical geography was obtained from the University of Windsor, Canada. He is author of 3 books: The Science of Global Warming Remediation, Confronting Global Climate Change, Experiments and Applications in the Tropics, and Geobiotechnological Solutions to Anthropogenic Disturbances, a Caribbean Perspective. His current research includes repurposing and remediating bauxite waste, cold water starch dissolution against deforestation, and humidification of sweet potato stem cuttings in dry soils. Dr. Harris, the stage is yours.
All right. I'm going to stop sharing, and there's his slides. Okay, so you could get started.
Are we ready?
Yes, yes.
Okay. I'll start off with this profound series of eloquent verses from the psalmist David. The earth is the Lord's, and the fullness thereof, the world, and they that dwell therein. For he hath founded it upon the seas, and established it upon the floods. Who shall ascend into the hill of the Lord? Or who shall stand in his holy place? Psalm of David 24, 1-3. An article appeared in the Daily Gleaner, 25th of the 8th, 2008. Less water vapor could ease global warming. And we placed that article because water vapor carries with it extra heat from the condensation that occurs inside of the muffler of automobiles. So this is pointed out because global warming conditions are not just carbon dioxide, not just methane, not just nitrous oxide related, but also water vapor, because we see the water vapor condenses and the condensation releases heat. Now that heat is also added to the global warming situation. And many people say, well, okay, it's positive feedback. It's going to happen again. The water vapor is just a cycle. But let's remember that the hydrogen for that water came from fossil fuels. The second thing is that that same water will be, yes, reheated and recondensed, but some of that water will be lost in the earth through a process called connate water, deep down into the groundwater reserves. So in other words, what we're saying is that it's not just carbon dioxide, methane, and nitrous oxide, but also extra water vapor coming from fossil fuels. So the situation is serious on Earth. I put this here, which is the solar wind, the particles coming from the sun, and they cause collisions in the stratosphere. And some people may think that, well, you know, it's not human beings who are causing global warming, but it's extraterrestrial. The fact, however, is that all these activities in our stratosphere, including the large aurora display that we had a few weeks ago, they have not throughout all the years increased the temperature of the stratosphere. Yet the temperature of the troposphere is being increased. So if we have all this activity coming from the sun, which has to pass through the stratosphere before reaching the troposphere, and yet the stratosphere has unchanged temperature regimes, but we in the troposphere are increasing, then that tells us something, that it's human beings who are causing these changes. Okay. That's just a bit of background there. Okay. I'm not going to spend the morning talking about the evidence for global warming, but just in passing, we can see here that I think this is a NASA graph from NASA showing that the observed changes to climate. You can see where the natural forces are, in balance. It goes a little up and down, but it corrects itself without our interference. So we have to get our act together. And it's like a set point. Your human body, as an example, all these systems are related, the inorganic and the organic there's a plan to keep things in line. And we have 37 degrees in our bodies. Look at that. It's going to go up a little, but it always comes back. It always comes back. It's built into the system. All right. So this is just a microcosmical example of what's going on in our environment, in our human bodies, in all living things. This homeostatic level that is kept at a particular temperature. Okay, let's see where we go from here. Okay, so I'm just going to look at some devices that we can use to ameliorate the global warming conditions that are occurring in everyday existence. What we can do at home, basically, not just what's happening in the scientific laboratories, which is out of reach of most busy people, but what they can do at home to reduce the effects of global warming. And one of these is this. When the surroundings are hot, concrete floors can absorb heat and still feel cooler than surrounding objects. Therefore, using concrete floors to refrigerate foods could substantially reduce global carbon dioxide. How do we do that? Well, I actually started an experiment here a few days ago. I had some green tomatoes. All these tomatoes were green when they were placed on the floor. Now, the top one is on a tiled concrete floor. The bottom set is on the same tiled concrete floor, but resting on cardboard. So the bottom tomatoes are resting on cardboard, and the top is on the bare concrete floor. Now, let me just say that these tomatoes, they were all green when they were placed on the floor. 15 of them were placed on the concrete floor, and 12 of them were placed on the cardboard. And you can see, now this is a couple of days, 3 days after it was. 3 to 4 days, this is what we found. We found that we have 4 out of 12, 4 out of 12 on the cardboard remained green, and on the concrete floor, 1, 2, 3, 4, 3, 6, 7. Is that 7? 4 and 3, 7. 7 out of 15. 7 out of 15 on the concrete floor remained green. So we have a big percentage difference here, because 4 out of 12, that's 25%. 7 out of 15, this is almost 50% up here, still remaining green. All right. Yes, this is an earlier date. You can see what's going on. I think this is day 2. And you can understand what we're talking about now. Look at the left-hand side. Okay, it's all green over the left-hand side. Okay. All right. Now, I got my students in a biology seminar. I had them do a chi-square calculation to see if it's just it just looks like the concrete floor is doing its job, or we have statistics to prove that. And the students were tasked with working out whether the difference is based on a high confidence scientific conclusion, or it's just feeling and speculation. Okay, so they use the chi-square calculation there, that technique. I won't bore you with all these details, but this is what the students did. And they got chi-square equals 7.75. Now, if this test works like this, if you have the calculated chi-square being higher than the critical chi-square, which you get from a table of statistics, then there's something going on in this experiment. You know, the hypothesis is that something is unusual. That's all it tells us, but that's very indicative of the conclusions, meaning that the two samples are not responding the same way. That's what it's telling us. So let's see if the chi-square is smaller or larger than the critical statistic. Okay, and we went over here and they continued working. You see here at alpha equals 0.05, the critical value is 5.991. And remember that what we worked out was 7.75. 7.75 is greater than 5.991. So we reject the null hypothesis. This suggests that there is a significant relationship between storage method and ripening rate, with the concrete floor appearing to delay ripening more effectively than the concrete box. And these are the words of one of the students in the class. And all the students got this same result. Okay? All right. So therefore, that tells us that the concrete floor can act as a refrigerator. And it may seem strange, but you go to the supermarket and the storage of those vegetables are not in very cold conditions. They're just a little colder than what's going on outside. That chilling, and that's what the concrete floor does, because the concrete floor is connected to the earth. That's a heat pump, and the earth pulls heat through that concrete floor. So instead of having 2-3 refrigerators in our houses, a big freezer, what have you, why not use up your concrete floors? Use up your concrete floors, and that will cut down the carbon dioxide going up into the atmosphere. Okay, now let's move on. Yeah, and this is telling us something here. Look at the specific heat capacity of granite compared with the heat capacity of concrete. You see what's going on. It would seem that the paper should take longer to heat up than the concrete. But what the concrete has over the paper is that the concrete, as I said before, is connected to the ground. The paper isn't. And besides, the concrete is a much larger density and compactness, and there's more stuff in the concrete. You can't beat the concrete, even though the paper is supposed to take longer to heat up, but that concrete is connected to the ground, and that's probably the main explanation here. All right, now we move on from home refrigeration, to smartphones. Everybody likes to have their smartphones. Now, just look at this. The World Bank says that 75% of the world's population owns smartphones. Now, that's a staggering statistic when you consider that 75% of the people in the world are poor people, basically. But they've got their smartphones. And so the 24-hour energy consumed by a common smartphone battery, including the amount of energy needed to charge a fully depleted smartphone battery and maintain that full charge throughout the day, is 14.46 watts. And that's coming from the Department of Energy, United States, 2020. All right. Now, what we're trying to do is to see how much energy, how much carbon dioxide those phones are putting in the atmosphere. In the USA, the national weighted average carbon dioxide marginal emission rate for delivered electricity in 2019, 1,562.4 pounds per megawatt hour, which accounts for, okay, so how many tons of carbon dioxide does charging smartphones place in the atmosphere per year? Answer, 124,000 metric tons of CO2 per year. Okay, so right away, it's telling us sometimes we can turn. No, I'm not saying you should turn off your mobile phone. That's probably a dangerous thing to do, right? But sometimes some people have 2, 3 phones. What do you need have 2 or 3 phones for? Yes, well, turn the business phone off when you're not on business, and that will help the carbon dioxide. Turn them off if you don't need them. Okay. Now, during World War II, each American soldier carried, I learned this from an American friend I had. It is an older man, actually, a friend of my parents, but he told me this way, way back when, that in World War II, each American soldier, he was a soldier too, he carried a hand-charged electric torch, just as mechanically powered hand squeeze flashlights are considered a green technology. We all know what I think we all have seen these charger things that you squeeze with your hand. The potential invention of smartphones charging. Who is going to invent a smartphone charger, a hand squeezed smartphone charger? Who is going to invent that? I'm sure they can do it, but nobody is trying to do it. Why? In this manner, we could significantly reduce the amount of CO2 placed in the atmosphere. I made this call about 15 years ago at NCU, Northern Caribbean University, one evening. I made it to an engineer who taught there. And I said, this is your challenge. I have not heard from him since. Okay? But maybe he's still working on it. All right? So, where is the smartphone hand charger? Squeeze your phone. Squeeze your phone with a spring in it and charge it. It's easy. It shouldn't be hard to do. It should not be hard. I'm no engineer, but I know it's not hard. Moreover, the batteries of such devices contain heavy metals and toxic chemicals, which often end up leaching out toxic material into our environment. So, if you want to save your environment, let's agitate for the hand charging mechanical phone charger, because that will prevent these batteries. Where is the batteries? Where are your phone batteries? Some people change their phones every 6 months. Where are the batteries? Ask them. They don't care. Okay? If mechanical charging were to be practiced, the smartphone batteries would last longer. And the physical exercise that these people that exert in charging their phones while they're walking to work. You're squeezing your phone while you're walking, and you're charging your phone while you're walking. While you're waiting on your bus, you're squeezing your phone. And left hand, right hand. It would improve the health of all phone owners. It would do that. Okay? We would lose weight. You can lose weight because of that. Use your phones. Use your phone as your diet, your phone, to lose your weight with your phone. Reducing CO2. What are the recommendations? Another a tactic. This is by Crooks 2021. An Android phone turn on and other processes has other processes running in the background and takes increasing time to charge. So he recommends powering down your phone before charging it. If it is desired to keep the handset on during charging, activate airplane mode, disable your wireless technologies, etc., etc. Each of them draw on your phone's battery even while the device charges. So to cut charging by as much as 25%, he suggests first swipe down from the top of the screen to open your panel, tap the airplane mode. Alternatively, launch the settings app and navigate to network, toggle the airplane mode switch. So therefore, these are the techniques that he's telling us to do. Of course, we go to the internet, and this stuff is all online. This stuff is online. It's nothing new I'm saying, right? Because I got it online. Okay, but we need to be activated. That's the problem. We need to be activated. Okay, so let's move on. All right, now another device here. This is now those of us who live in colder countries, we have our double glazed windows. Okay, we know them, right? Where we have this spacer here in the middle. This is the mechanics of the double glazed windows, and we have our suction thing taking here. We have our containers here. This is the outside for the rain to go off, and this is on the inside. Now, this is empty space between 2 and 3. Empty, not empty space, because air is matter. So it's filled with air. But the problem with air is that air has a much lower heat capacity than water. Now, this is, I'm suggesting this for people who live in hot countries. You know, if you can have double glazed windows work well in hot countries too, because it keeps out the heat. Just as it keeps out the cold in the cold countries, it keeps out the heat in the hot countries, because the heat has to pass through air, and air is a resistance to heat. But what is more resistant to heat than air? You know what? Plain old water. Drop some water in here in your smart windows. Put some water in there, and we'd be surprised to find out how difficult it is for the heat to come into the house from the outside, because the heat has to heat up that water. You and I know how difficult it is to boil water. You ever boil an egg? Which is easier, boiling an egg or frying an egg? Boiling an egg, that water takes a long time to boil, right? But because water has a very high heat of capacity. So fill your windows with water, and you will save the earth. We will cut down the carbon dioxide going into the atmosphere. All right, now we come to something here which is more about the environment rather than climate change. But as Dr. Murray said, all these things are related, right? Now, this is a chair we've got here. At least, to be honest with you, this is a chair that I've been sitting on for several months, and I'm at fault here. Look, I've been taking, listen, I should know better than this. But fortunately, I have covered this chair. This is vinyl, and it's cracked. You know what's happening? All right. Why is vinyl so soft? Let's go back. Sorry about that. Right. Why is vinyl so soft? Because vinyl contains phthalates, plasticizers. And these plasticizers, these molecules, they don't polymerize. They don't mesh with the rest of the vinyl. They are free to move. That's why the vinyl is so soft and supple, because the molecules are not joined up together. They're not joined up to anything. They're just hanging around in there, waiting for your vinyl to crack like that, and for the phthalates to escape. And look at what they do. They can seep through the human body, through your skin. I'm pretty certain, I'm almost certain I've got some in my body, because I've been sitting on this cracked chair for so long. And as I said, I should have known better. Anyway, that's another story. Fortunately, I've passed the age of reproduction, so therefore it's not going to affect my any offspring. So, but it's mainly dangerous to people or children and their reproductive organs. Yeah. So let's look here now. During manufacturing, some toxic compounds remain within the plastics. Degrading plastics, they release these residual monomers into the environment, with chemicals reported to leach from plastics, including bisphenol A, benzene, phthalates, phenol, etc. And the thing is that these things, they can get into our water. So people who are sending these things, as Dr. Murray said, all these things are related. If you are sending these things to the garbage dump, then forget it. They should not go. I'm honestly saying it's better to cover them. It's better to keep this chair and recover it. If you recover this chair with some good thick cloth or some tough paper, then this chair can go on for as long as many years, and then we'd be saving the environment. Then we'd be saving our groundwater, because what if these things get into our groundwater and people drink the water? You know what's going to happen to them, especially children. I'm not being a prophet of doom, because it takes a long time, But whether it takes a long time or not, you don't want to start doing that. Okay? Okay, because climate conditions combined with microbial action progressively degrade the embrittled materials into small fragments known as microplastics, etc. By such processes are hydrolysis and ester bonds, photooxidation due to UV exposure, thermal degradation, heat microbial degradation. These things get out and into our environment, which it's already over the top. As I said, we cover all vinyl furniture with cloth or tough paper. Recommendations. Okay, let's move on from here. Now, this is another thing. This is what we have here. Let's get into some foods now. We talk about dairy products. Look at the kilograms of carbon dioxide, read at the top, please, per kilogram of product from West to East Canada. Now, we're talking about regular cheese. This is the cheese in the blue, and this is cottage cheese. Now, we can see over here, we should be having our graph on the left-hand side here, but you can see what it means. Cottage cheese puts 4.2 kilograms of carbon dioxide per kilogram of cheese. Just imagine, 4.2 kilograms. That's unbelievable. I'm not saying we should stop eating cheese, but let's moderate on it just because of this, right? And if you are, maybe you can start eating cottage cheese instead. Look at cottage cheese, a lot better than regular cheese. But what's even more, how should I put it? The word I'm looking for, it's deceptive, insidious is the word I'm looking for, is this trend from what is it? From west to east. In Western Canada, the cheese is putting much less carbon dioxide in the atmosphere. Let's go back to that. Sorry about that. Than in Eastern Canada, right? Look at this. You have a trend going east, and the same thing for cottage cheese. Now, let's think about that for a while, because we're going to find out that the same thing is happening for regular cream and sour cream. Western Canada, British Columbia, go across the prairies to Eastern Canada, it's more carbon dioxide. The same thing you're manufacturing, you're producing, and the eastern provinces are causing more carbon dioxide. Let's go over to another one, and this is milk powder. Now, we all know that milk powder is a magical tool for people who are impoverished and into disaster areas. You need milk powder, I suppose, but listen, we have to face it. Milk powder is very great in increasing global warming, because you have to evaporate all that milk. And what do you use to evaporate it? You use fuel from fossil fuels, heat from fossil fuels to evaporate this milk powder. Okay. So, and we have this trend. Look at this trend going from west to east in Canada. Same thing down here. Even fluid milk, which gives much less carbon dioxide in the atmosphere, fluid milk, it still has a slight trend going that way. And we can go on and on. Look at butter. Same thing. The western provinces, much less carbon dioxide than the eastern provinces, going from west to east. All right. I think I'm running out of time here. I don't want to go over time, right? But let me just go on. And again, we have frozen dairy products, not that much, but still the trend is continuing. But you can see which one is taking more, emitting more carbon dioxide, concentrated in it. And listen, all of these things, it's not just that the product is emitting the carbon dioxide. I think we can all agree on that. But it's a process that that gives these items. Look at cheese again. A great disparity between regular cheese and cottage cheese there, right? Okay. Yogurt. You can compare yogurt with frozen dairy products. And this is a person, all those people who love ice cream. Why don't you substitute yogurt for ice cream once in a while? Because if you do that, you'll save the planet. Because look at the this is this is what frozen products give too. This includes ice creams, frozen products. Look at the carbon dioxide it takes out of the atmosphere. Look at that. Look at that. Compared to yogurt, which is number one. Okay, yogurt is much. This looks like maybe about nearly 1,000%. Okay, so that's what we're talking about. What we choose to consume. And we have the environmental harm of cheese production. Look at cottage cheese way down here and look at cheese up here. So again, the process that's involved. Okay. All right. So in every category. Now, let me suggest the reason for this, right? And what relationship to the world population does this have? Now, I'm talking about Canada. Everybody could not live in Canada to choose the kind, because if you even live in the eastern provinces, you can choose cheese that is made in BC. That's what I'm trying to drive at. Okay, so if you go to the supermarket and you see this is what it's telling us, because the eastern side of Canada is colder than the western side. I think that's the key. We have the Labrador Current running down the side of Newfoundland in the eastern part. Over in BC, we have the warm North Pacific Drift, and it keeps British Columbia warm. Okay? When I say warm, I mean relatively warm, of course. Okay? So there's not that much to heat. To heat, you have to spend using all this heat in the eastern provinces. So it's telling us that, I'll give an example here. I know New Zealand makes probably the best dairy products in the world, probably. I mean, they're very good at that. That's their stock in trade. But I would say New Zealand is a kind of a cold country, and I would say it's better to get your goods, in my view, get goods made from warm countries rather than from cold countries, because at least in warm countries you don't have to have all that heat to keep things to keep things warm, etc., etc. All right. So I would go as far as to say choose your products. I don't want us to stop the economies of any country. I mean, this is, but I leave it to all of us to make our own decisions. Okay, because the environment is more important than any national boundary. I can tell you that. Now, the environment of fluid and powdered milk. Let's look here again. The environmental harm of fluid and powdered milk. Yes, we see here the fluidized milk is much, with a few exceptions, it's much more benign to the environment than the powdered milk. So if you can avoid the powdered milk, do so. Yes, I know it's more efficient because there's less water in it, etc., etc. We can, and in fact, there's an argument. There could be an argument, for that. But at face value, then there are other. I think it's overriding. The evaporation that's required. That's the problem. The evaporation of that milk. All right. And the same thing happened. Look at this now. Quebec, Maritimes. This is going towards the west again, and you can see the lower carbon dioxide going on. It just happens over and over, and I think the evidence is incontrovertible. Now here we go to the house. We have a house, or we have an office, and okay, I won't take much longer here. I think we're coming down to maybe just a few more slides. Okay, now if and this is what we did here. Evaporative adiabatic cooling, where a portable absorbent surface continuously converts thermal energy to kinetic energy in a closed system, thereby cooling hot air while minimizing the use of fossil fuels with the aid of an extractor fan. Now, this is for hot countries, basically, all right? Or for the summers in the cold countries. Now, we have a window here. The heat is coming in from the outside. Use that heat for cooling, right? Use the power of the heat to cool your room instead of wasting so much on an air conditioner all the time. This is wet newspaper. Wet newspaper. Get, maybe we can sew newspapers together because newspaper is very absorbent of water. And it's free. That's the main thing. Or if you have a big wet cloth or blanket, put it up against your window in the summer like that and keep that wet. You know what's going to happen, right? Okay, now, I know the heat from outside is going to cause some of the evaporation, but there's heat inside the room, okay? Or we can close the window then to keep out the sun's heat and use the internal heat of the room to evaporate this water. Now, some people are going to say, yes, but we're going to have great humidity in the room and people are going to feel hot. That's why we have an extractor fan at the top, a little extractor fan. And don't forget that water vapor is not going to stay on the ground because water is what? Lighter than air. Many people don't believe that. Water is lighter than air. Water floats on top. I'm not talking about liquid air and liquid water. If we're talking about liquid air and liquid water, then which one is heavier? So if we're talking about if we're talking about gaseous water and gaseous air, gaseous water is lighter because water vapor goes up. All right. So the water vapor is going to go up naturally to the extractor fan. The extractor fan is going to pull it out. So we won't have that aspect of humidity to make people feeling hot. So this is it. Use your heat, your body heat, to evaporate that water, and it goes up. And the room will feel a bit cooler. All right. Okay. So let's move on. And here we have an even more elaborate contraption here. This is from Northern Caribbean University. This was published in the book this year. This is what's going on. We have some wicks here, and we have a water tank down here. And this is based on research done at Northern Caribbean University several years before, where an evaporator, I forget the name I call it now. Yes, but that's what we did. And we used it in dry soils, but we have repurposed it for cooling a room. So we have this denim cloth. We know denim cloth work best, and pulled up as a wick, pulled up the water going through here. Now look what's happening. We have perforation here in this tube going up, so that we have water. What do we have here? Yes. Water going in. That's right. Water going in. Water goes in from people sweating or whatever, and this extractor fan. Sorry.
Oh, go ahead.
Yes. Yes. This extractor fan is pulling the water vapor through here and pulling everything going on. We have two extractor fans working, and they're moving the water up and out. But what's happening is that the heat for evaporation is being pulled from the room. So the water is staying on top. The water is staying on top up here, and people are cooled down here. Okay. All right. Okay. And another device that we can look at, this was done. All right. Yes. We made some paper here at NCU. I think my battery is going. All right. Yes. A study. What happened here is that we had a study, and we looked at a softwood that we have here, and the softwood is called spathodia. Okay, Spathodia, and Spathodia is an invasive species in Jamaica. The other name for it is the African tulip or flame of the forest. And what our objective was, we wanted to you know to to make paper out of it. All right, because in order to make paper, you have to remove lignin, and the removal of lignin takes a lot of oxidants, like chlorine, etc., and sodium hydroxide. And so we used a technique called alcoholic alkali alkali cold water dissolution of starch. All right, we used that to take the starch out. We got it from fermenting bamboo, and this was done by Dwight Rose, who is still at NCU, and myself. We worked on that in 2019, and we got that paper done. And so we reduced the amount of sodium hydroxide was reduced in making that paper. That paper. Let's see if we have a picture of that paper. I'm not seeing it. I'm seeing it. But what happens is that the paper strength was increased, and so that was what we had there. People say, well, why are you making paper? Well, you have to start somewhere. Anyway, what we also did, what we also found out is that this method, with this non-energy, this non-fossil fuel method of removing starch from wood, it cures the wood and makes the wood last longer. So we can use that wood for that invasive tree that we've got in Jamaica called the Spathodia. We can use it to make walls and ceilings. All right, because if we never remove the starch, that wood rots, that it gets fungus infested very, very readily. So you can see here these samples. Look at these samples. Now, this sample was not treated with alcoholic alkali, not alkali, naturally coming from fermented bamboo. This was not treated. Okay, zero, and it rotted very quickly. And look at the holes in it. We used a drop technique, dropped a spike into these woods, a sharp spike, and look what it did. It went deep into these woods, and this was treatment with the bamboo, and it did not go so deep, and it never made so many impressions. And this was the best one. This was a highly resistant one. So we can see what's going on there. It caused these things to happen to make this wood last longer. Now, what's the significance of that? Well, if you have an invasive wood species, and that wood species can be taken out of circulation and used and not decomposed, because decomposition produces carbon dioxide. If you can save your wood for a useful purpose, preventing decomposition, you are taking carbon dioxide out of the atmosphere. All right? And there's so many buildings that are using dry walls, gypsum. Now, gypsum is one of the greatest producers of carbon dioxide in the world, believe it or not. It's second, I think, only to cement manufacturing. All right? And if you can use your wood at construction, or some people may say, well, wood can cause fires. Well, this is what we found out about this particular wood. All right? Look at this. We try to burn this wood. This wood has fire resistance. Fire resistance. Okay? So this is what we've got here, where this wood here would not burn very easily. We tried to burn it and see what happened. Okay? All right. So this is a paper we got from that wood of this Spathodia, low sodium hydroxide. All right? Or a picture of the simulated picture, let me put it that way. Now, I think this is maybe the last one we're going to talk about now. And, drought-resistant crops during climate change. What drought-resistant crop? One of the greatest drought-resistant crops in the world is cassava, but cassava has problems because bitter cassava at least, produces cyanide. And there's a big, big, big problem in places like particularly Africa, where people feed on cassava morning, noon, and night, especially in some of the rural areas in Africa. And what it does is that it's not processed properly sometimes, and it causes a disease called cancer, crippling of children. Thousands of children, believe it or not, in Africa are crippled permanently per year, with a disease, they paralyzed, they can't walk properly, etc. And so what happened? We came up with a treatment for the cassava. Basically, yes, it's not a totally original on our part because we sort of added to another treatment that was done in Australia by a great researcher at Australian National University. I forget his name right now, but I communicated with him, and he communicated with me while I was at NCU, and we, a student of mine, Charles Cumson, he and I, and the power of God helped us to find a method of treatment depicting of moisture pressure combination treatments. And we brought and that treatment, not we, the treatment brought the cyanide right down to lower levels than even Dr. Bradbury's method from Australian National University. But if it weren't for Dr. Bradbury, I don't think we would have got it. So I think the credit should go to him and to and I don't know how we got it to. I still say it's the creator who helped us to do that because I don't know how it happened. I mean, I know how it happened, but listen, it was just mind-boggling, All right, so but it wasn't it didn't come from us. Cyanide removal from cassava, and so we got that. Now I've got many citations to that on the internet. People have read that article, so I hopefully that has been helping to reduce the cyanide in grated cassava in places like Africa. I don't think I have too many more slides right now. Yes, I think that's it for today.
Okay.
I think thank you very much. Thank you for your patience and your interest in this presentation.
All right.
God bless you.
Thank you, Phaedra.
Well, thank you, Dr. Harris, for giving us a variety of ways that we can think about how we can help our planet Earth. From the simplest that we all can do, turn your phone off when you charge it, or at least put it on airplane mode. That's something all of us can do. If you have concrete floors, go ahead and optimize the use of that concrete floor for the produce. For those of us that have more time to do the research, think about where your food is coming from. How much wastewater are they producing? How much carbon dioxide are they putting in the atmosphere when they produce that? So these are things that all of us can think about. And so we thank you for presenting us with these ideas. For those of you that were on earlier, I was in the architecture program under Mr. Moreno. So when I heard Dr. Harris talk about the spathadia tree, I don't know how it's pronounced.
Pathodia.
Spathodia tree. I know Mr. Moreno has a green architecture seminar that's coming up in a couple of weeks. Make sure you guys tune into all of them. But that piqued my interest. Ooh, is that something that he's going to take notes on and do research on? But earlier on in our presentation, one of the participants talking about the refrigeration, amazing, Mary Alice Adams says, amazing, and it makes sense since our ancestors didn't have refrigeration, just talking about some of the more, in our fancy Western world, we call it primitive, but healthier ways of storing food. So if there are any other questions, what questions came to mind as you were listening to this presentation? Yes, Mr. Moreno.
Yeah, thank you, Dr. Harris, and thank you, Phaedra. It's really good to see you, Phaedra. Um, so we should catch up later. Um, so I like I'm not a I always preface these comments with I'm not a scientist. And I remember a time when my daughter's teacher in her junior high said, I want you to each get a sketchbook, but I want you to have this special um, biodegradable, energy efficient, like sustainable a book. It was like the sketchbook that was um, designed to be sustainable. But he said the only place to get it is in South Bend. So he was encouraging every family to go to South Bend to drive their, gas guzzling vehicles to South Bend to get this sketchbook. And I thought, it's great to have the sketchbook, but if you're encouraging that travel, so then there's an offset. And so like, how do you calculate all of this? So my question for you is when you're talking about the butter and the milk and the cottage cheese and one side of Canada and the other side of Canada, and you're encouraging us to buy from one source, it has to be transported then. So what is the offset for us here? And what is the energy trade off or the pollution to the earth by the vehicles that we're depending on?
Yes, well, uh, uh, well, one way of answering it is that um, would it not be transported anyway, regardless of whether or not we we purchase it, right? If we um if we don't purchase it, if we don't purchase from let's say Western Canada, if we're living in the East and we don't purchase from Western Canada, all right,
Yeah.
then then basically if there's all right, let me put it differently, okay. um According to how uh the uh, the politics of the situation is situated, I understand what you're saying, but the transportation of it uh happens in such huge bulk. It comes across on trains, uh, and the trains will always be running. The trains, okay, so they may get an extra car for the extra butter, but really, if the train runs, the extra that it carries, uh, I haven't checked it out mathematically, but I would not think that extra loads on the train would have offset the vast amount that is moved from country to country. But I take your point definitely. That's something to definitely think about.
Yeah,
But
and train, the difference between train and trucks. Like, how do we know what, one is more polluting than the other? And how do we know how it's been transported? I take your point too that, we can like if it's already been delivered, we have a choice of delivering of choosing, one thing or another and sort of maybe affecting the supply and demand. Perhaps I'm not sure just as a regular guy at a grocery store, I'm not sure how to make the decisions.
no, I think you have a very strong point, and I'm not going to say that I had not thought about it before, but I had not really thought about it as seriously as you have. And that's a point. That's something. I thank you for that, and I have to sort of reset and think more deeply about that, I must admit.
Sure. I have a question also about the window. I'm fascinated by the cooling effects of putting water in the window. The diagram showed just a little bit of water. And then, but your word said, fill the glass. My thought was if there's a little bit of water in there, then it's going to create steam and it's going to obscure the view and it's going to look, the view out would be obscured. But if it's filled with water, I'm fascinated by that prospect more so. So is the glass filled or?
No, no. What you did not see water in the glass. Maybe you were looking at the spacer.
In between the glass planes.
Yeah, yeah, yeah. We there was no water in there. You're probably looking at a spacer in
Oh,
there.
okay, gotcha,
No,
gotcha.
no, we didn't.
Okay,
No, there was because that concept of water in there is my idea.
yeah,
I did not make that diagram, but I just took that concept of putting water in there. So the original the person who made that diagram was not thinking about water.
gotcha. Very cool.
All right.
Yeah, yeah. So it should be filled with water, totally.
Okay, thank
So,
you.
Okay,
so one of the things that I think I learned from this is that in terms of environmental impact, we shouldn't just look at the product, but we should look at the process. And a lot of us don't really look at the process. We just, compare product to product, just look at the product, perhaps the labels, but we should also go deeper to find out more about the process. Would that be a fair assessment of what you're saying?
Yes, yes, yes. But let's face it, people judge products mainly on the cost. All
Mm-hmm.
right.
Mm-hmm.
And but as Mark was saying a while ago, right? If it's going to cost more, okay, if it's going to if say the product is coming from two distant sources and both sources are the same distance from you, let's say the transportation costs are roughly equal, then you should, in the interest of global warming, you choose the one which had a less extreme climate. Okay, because then you know that you are cutting that cost out if they are the commensurate prices. So we choose based on those things. So I agree with you.
Bridget,
we have a
Bridget,
yeah.
yeah, Bridget.
Yeah, thank you. And thank you so much. Good to see you, Dr. Moreno. It's good to meet, is it Phaedra? Would love to meet you when I heard
Phaedra.
your bio. Would love to chat with you. Dr. Harris, thank you so much for an extremely relevant presentation today. Relevant not only to science, but to everyday lives. I'm wondering, sir, if I don't know who's gathered here and our specialties professionally, but my mind goes immediately to an economic model that could be developed to respond to Dr. Moreno's question, because there is something from a CARICOM posture for the geopolitical importance of the breadbasket of the world being in those regions. And I can see that the question from the north, from the colder climes, would be important to them, but also important to us as it impacts the trade. So if there could be a corollary economic model to show the value of transporting certain products to share with the world, I think it would be most welcome. Again, thank you so much. I will be back for all the other. Let me salute Dr. Desmond Murray. For every time I plug into his meetings, my mind is blown, And I'm wondering, sir, if there is something that you're developing for the layperson, something that could just say these 12 points of good living. Last night I sat because I was stressed to a half a pint of ice cream. And I am
Okay.
I am now a convert.
You do have a pint, I do a pint.
Oh dear. So let me
Anyway,
apologize to the universe for my contribution. Hello, Dr. Marie. Hello, Dr. Marlene. Hello.
Okay.
I do want
Thank
to
you so
shout
much,
out.
sir. And I hope that you can distill this very vital, important knowledge to some kind of a takeaway, some kind of an interactive booklet from all of your scientific presentations for regular people to be able to buy in to all this wonder. Thank you all.
Okay, good idea.
May I just make a quick comment on
Yes.
what
Yes.
I think it's Bridget, former speaker,
Bridget?
just said.
Mhm.
Yes. I think you, Dr. Murray and Dr. Moreno, you struck a very important point there, which was amplified by the suggestion by Bridget, about foods imported into a country, and whether CARICOM, whether a political economic system could take on these procedures. Are we in the bottom line? Are the hot countries, like, let's say, are we importing stuff to suit luxury tastes? Or I'm not trying to be a socialist now, or some kind of dictator, but I'm just saying, do people want these things, or are we trying to make them like them without them having any initial interest in them? Are we forcing these things down their throats at the expense of climate change?
Yeah, that's
That's
a very important question, especially in democracies. I see in the chat, Della put two words in that probably helps a lot. Buy local. Buy local. That, I mean, it's not always possible or
Yes.
feasible, but wherever possible, buy local.
Yes.
That,
Absolutely.
minimizes the transportation aspect.
Yes.
Good idea, Della. Do you want to expand on it, or your
Thank
two
you,
words
thank
are good
you.
enough?
I mean, yes, it does help to ease upon the transport costs, and not only that, it supports the local entrepreneur, it supports local mom and pop um enterprises, and we some ways away from solving this climate crisis, and every little step and every little thing we can do as
Yep,
the average citizen will help. So yeah, that's my little contribution there, and I think it will go a long way.
it's a great contribution. Thank you for that. So another question I have is, you talked quite a bit about the evaporative cooling system, and it sounds like in principle it could be applied in multiple places, buildings, and so on. I was just wondering if you've thought about it being applied in like greenhouses.
I never really thought about it being applied in greenhouses, because um, I would have thought that greenhouses were made to increase heat. So I mean, the 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 objective of the greenhouse is to improve sunlight and heat. I would have thought. I don't know if there's something I'm missing from your question.
Well, we know of a technology based on a previous presentation that one of the ways of achieving uh, low or zero carbon was to remove the humidity that is in the greenhouses. And essentially, that's what I think your evaporative cooling system does with the extractive fan. Um, it, to me, sounds like it's another way to remove the humidity and then reduce the amount of energy that's being used by the greenhouse. It's something to look at, I think.
You're saying that the humidity is connected to excess carbon dioxide.
Excess carbon dioxide, the energy that's used to power the greenhouse, the moisture, all of that I think contributes. And one technology that we were exposed to is uses, drains out, removes, reduces the humidity as a way of saving energy. And I'm just suggesting, this could be something for you to look into as an application of your technology of evaporative cooling systems.
Okay. I'll think about that one.
All right, sounds good. Okay, other questions? Mark, you have a short one because we want
Yeah,
other people a chance to.
yeah. Oh, I'm happy to defer.
Go ahead if you have a short. Yeah.
The water tower, Dr. Harris, reminded me when I was a kid, my father had a restaurant and he had a thing that was called a swamp cooler. And that water tower and the evaporation system and the extractor. I didn't know how it worked, but that's what we had instead of like conventional refrigeration. That's just a comment. When I was looking at Della's comment by local, that's the conventional wisdom. But what you told us today is that things are produced with more efficiency and better for the climate in other places sometimes. So we need to get them from here to there. And so I'm trying to tie Bridget's comments together, which I might have understood to be that is there a way that we could have a label on top of on top of products that speaks to the efficiency and the effects of this product on climate change based on the measures of its transportation, its process, a rating system that people like me who can go to the grocery store and pick something based on that, along with nutrition value and recycling value.
Yeah.
Well, there is such a system which operates in scientific circles in Europe called the life cycle analysis.
Yep.
Each product has a rating based on whatever is done to the product before delivery to the consumer. I'm not sure, however, I'm not sure if it's listed on products in Europe, but I think that's what is necessary. Yes, absolutely.
Thank you.
Yeah. All right, guys, we are getting to the top of the hour of 11 o'clock here. So if there is one more question or comment, we could take that, but then we will probably need to wrap up. So I see. Go ahead.
May I respond to the question in the chat and suggest not unseriously that especially in our region, the Caribbean region and certain other regions, music, the song, rap, soca, calypso are extremely good communicators for lifestyle change. And we should look into that. Dr. Floyd Morris, sitting in Jamaica, perhaps Dr. Harris is familiar with him, Senator Floyd Morris. He just published a book on the reggae musicians of Jamaica, those with special needs, I should add. And it is such a powerful communicator when we put knowledge and information into song and verse. I would respectfully submit that. And Dr. Murray, you know that you are a writer.
Okay. So I assume you were responding to Sonia's question about getting the average citizen.
Yes, sir. Yes.
Yes. Yeah. So I think another way of saying what you just said too is that the entire culture right? Because those are the music,
Yes.
the calypsos, the writing, all of
Yes.
it is part of the culture.
Yes.
It has to be a full circle, so to
Yes.
speak, of cultural things
Yeah.
that would towards and get people interested in climate change and reducing pollution and all of that.
Yes. One of the things Dr. Moreno alluded to um, is, or someone asked the question, what, or you did, what is it that has folk using these products that are not good for them? But it is an entire state of efficient marketing where we have marketed to the developing world that the products of the developed world, now that we can deem them inferior, are better. And so you take the raw materials that are from immediacy with the ground, you repackage them with preservatives, and you sell them back to the people from whence they came
I
in a
know.
fancier, more delectable package with lower level food. And so we as Caribbean scientists and educators, uh, Phaedra, should go out there with the gospel of of better living and let our people know, hey, stay home. You don't have to travel to eat. You don't have to travel to put the superior cream on your skin. You have it where you are, and help our economics personnel and our political personnel to have our peoples with better lives. Thank you.
Okay, so Phaedra, you want to bring things to a close?
I want to thank everyone for their participation and their input. And we definitely were given a lot of nuggets to think about. How do we make this relevant to the culture? All of us on here admit that there's something's going on. And we also know that there are things that we can do. So, what is our role in helping to inform others make more informed decisions? So, that is our call to action. Turn off the phone when you charge. Think about, how do I get people to buy local or do things that are more sustainable? And so, with that, those are my final words. I'm glad to meet everyone here. I'll just for the sake of communicating and keeping in contact, I'm going to drop my email address in the chat, and I look forward to seeing you guys on subsequent Environmental Fridays. Thank you so much.
Okay, thank you. So
Thank you.
I want to thank our guest for today, Mark Harris. I want to also thank Phaedra as our co-host, and want to thank everyone who tuned in to Environmental Fridays today. If it is Friday, it is Environmental Fridays. It is personal. See you guys next week.
Thank you.
Thank you very much. Wonderful show.
Desmond, can you stay on for a second so I can chat with you? And maybe Princella too. Do you have a minute?
We're
Yeah.
actually, why don't we do our own call? Because I have
Yeah.
some other people
Yeah.
join
Sounds
us.
good.
I
Okay.
was actually gonna, okay.